Welcome back to Broken to Built. Today we're looking at a component that keeps the world's heaviest machinery moving, a Caterpillar internal gear hub. This isn't just a casing, it's a high-precision spline interface designed to transfer massive amounts of torque. But under extreme stress, even industrial-grade castings reach their limit. We have a full-thickness fracture that has liberated a massive segment of the spline wall. To most, this is 500 pounds of scrap. To us, it's an engineering puzzle. We're going to design a custom steel exoskeleton to bind this fracture and return this tool to the front line. Our first objective is to reclaim the geometry. We're securing the fractured hub in the four-jaw chuck to begin the truing process. This is the foundation of the repair. Using a carbide-tipped boring bar, we are machining a series of precise landing threads onto the outer diameter. We aren't just cleaning the surface, we are creating a mechanical interface for our reinforcement. Concentricity is everything here. If our center point is off by even a fraction of a millimeter, the massive oscillating loads will tear this repair apart in the field. While the hub is being prepped, we move to the anvil. We are starting with a thick plate of high-tensile structural steel. Unlike the original casting, this jacket needs to be ductile, yet incredibly strong. We're hot-forming this plate into a perfect radius to mirror the hub's outer diameter. On the lathe, we are boring the internal threads to match the landing we just machined. This is high-stakes precision work. We are aiming for a mechanical lock that can withstand the violent vibration of heavy earth moving. This is where the engineering becomes a science. We aren't just sliding this jacket on, we are using a mechanical thermal hybrid lock. By applying specialized industrial lubricant and thousands of pounds of rotational force, we are threading the new jacket onto the prepped hub. As the threads engage, we are creating a unified metallurgical interface. The physics is simple but brutal. By pre-stressing the jacket, we are exerting inward radial pressure that actively works to keep the fracture closed even under maximum load. To the welding bench, we're laying down deep penetration beads using a high-nickel filler rod. This bridges the gap between the cast iron and our structural steel jacket. We're managing the thermal input carefully to avoid warping the internal splines. Once cooled, we return to the lathe for the final pass, machining the surface flat and tapering the edges for clearance. What was once jagged scrap is now an over-engineered beast, ready for another decade of service. If you respect the grit of the workshop, hit subscribe. We'll see you in the next build.